Babbling baby bats, simulated rats, the impressive memory of cuttlefish, and why, contrary to popular belief, some key mental abilities appear to actually improve with aging. Joining us now to help us understand some of the latest science stories in the headlines is University of Chicago paleontologist Neil Shubin. Neil, great to see you as always.
Great to be here.
All right, so let's start with that bat story. Researchers at the Smithsonian Tropical Research Institute have found that baby humans share a very interesting trait with baby bats. What is that?
Yeah, so this team was looking at bats, the sack-winged bat from Panama and Costa Rica. And what they would do is watch them in the wild, in their natural settings. They'd watch them develop. And it turns out the baby bats learn vocal signals from their mom, but they do so by a form of babbling, much like humans do. That is, they'll repeat a syllable over and over again, like da, 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 or ma, 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 like different consonants, obviously, they use, but something like that. And then they learn from their mother as they begin to babble. They begin to refine their language as they babble.
And as I understand, I think we have some sound of that babbling, so let's play some of that sound as I ask you this next question. So is this babbling a trait that's unique to humans and bats, or are there other animals that develop language like this?
Well, so far within mammals like us, which have hair and so forth, it's the bats and the humans. But it turns out that birds can do it as well, though they have a different kind of vocal learning. And so it's pretty, there it is, that's pretty cute.
Yeah,
it's pretty amazing.
It does sound a bit like a bird. So that's a baby bat there. Does this tell us anything about the evolution of language in general?
It does. It shows us that the roots of language run very deep, that they run outside our own species, that even bats and probably other mammals as well do this, so that the roots of language precede the evolution of our own species. So that's really fabulous.
So a lot of species are talking to each other in their own way. All right, let's move on to cuttlefish. A team of international researchers discovered that cuttlefish retain very sharp memories of specific events in old age. How do we know that?
Yeah, they're really remarkable. These are smart animals. They live about 2 years, and we know it because these researchers have.
So old age for them is relative.
Yeah, no, they live 2 years, but that's old age for them. It's like they're 90 by like 23 months, the equivalent of 90. But the thing about it is that they tested these cuttlefish. What they did is they put up little signals where food would be. And they did that over a period of time. They varied those signals, but they trained them in some ways, but they also varied them in others. Turns out that the cuttlefish were able to remember these signals throughout their lives, up into the day they died. So unlike humans, where short-term memories can disappear, in cuttlefish, they don't.
Very interesting looking species there. Is there any theory as to why their memory is so good in old age?
Yeah, so they store their memories in a slightly different way, in a different way than us. We store our short-term memories in a region of the brain called the hippocampus, which degenerates as we get older. That's why sometimes as we hit age 50, 60, 70, we have a hard time finding names. Well, cuttlefish do it in a slightly different way. They have a different structure to store their short-term memories, one that doesn't degrade as they age, which is pretty remarkable because the rest of their bodies age significantly in terms of their strength, their vitality, their vigor, but not their memories.
Speaking of memory and mental ability when we age, there's a study out of Georgetown University Medical Center that says, contrary to most of our collective belief, that there are some elements of memory that improve in human aging or as humans age.
Yeah, thank goodness, right?
Yeah.
I mean, so we were just talking about how short-term memory can degrade in humans. Well, what this team did is they gave individuals ages 58 to 95 a test. And this test required them to really think on their feet very rapidly. And it turned out some aspects of attention and memory actually get better with age. Others decrease. So it's a mixed palette, but it was a really remarkable discovery.
Okay, so what are the aspects that get better versus the ones that decrease? Well, you mentioned short-term memory decreases, obviously, but what gets better?
Yeah. Okay, so think of driving. There's 3 different components that are active when you're driving and hitting an intersection. One is alert, the other is orientation, and the other is executive function. So in terms of alert, if you're approaching the intersection, the alert phase says, aha, I'm approaching an intersection. The next is orientation. If there's a passenger in the intersection, orientation is when your brain focuses you on that passenger. The third is executive, and executive allows you to filter out all the other signals to focus on that passenger, independently. Filter out all the other sensory information to focus on that pedestrian. And so in this case, what you have is the alert function is decreasing in function, whereas the orientation and the executive ones are increasing. So it's pretty remarkable, and that was a very, very statistically significant signal over aging.
So maybe more focus and better decision making as you age. Does this have any implications for Alzheimer's or dementia research?
Well, the feeling is that these are learned, that the reason why we get better with these as age is not because our brains are necessarily working, physiologically better or neurobiologically better, but it's because we have learned these things. We retain that learning over time. So perhaps by reinforcing these kinds of things in elderly people and aging brains, that we can prevent deterioration in some ways.
All right, last story, certainly not least. Rat whiskers. Northwestern University did a simulation of a complete rat whisker system. What is the purpose of researching rats' whiskers?
Rat whiskers are really amazing. Okay, rats, they don't use their eyes as much as they use their whiskers. Their whiskers, they have about 70 of them, sticking out of the front of their head, of different shapes and different sizes. What they do is they allow them to see their environment through the bending of these hairs. It's almost like sight in them. And so somehow the brain is integrating all the signals from these different whiskers, these 70 different whiskers, to give a sensory picture of the world in rats. It's a really remarkable thing. And what the Northwestern team did is they said, well, we can't really study these things in living rats because they're too small. We can't do that. What we can do, however, is we can model them mathematically. So they did a 3D scan of the rat's whiskers. They vary in shape and size. And then they modeled what happens to them as the rat would enter different environments, as it put its head in a pipe, as it walked around a room, as it whisked around different shapes. And they were able to show how a rat can perceive shape and size and movement of air through its whiskers.
And the researchers in this article said it might shed light on, quote, the mysterious nature of human touch. How so?
Yeah, think about it. Let's say you're in a dark room and fumbling around with your hands, and you're against the wall, and you're looking for that light switch. What's happening? You're sensing that room through your hands, through your touch, and that is an incredibly complicated set of systems there that are working. Touch is amazingly complicated because it's tied to how we use our hands, how we use our bodies. It's tied to the motor piece as well, how we use our muscles. Think about holding a coffee cup. Without a sense of touch, you'd drop the cup. You would either squeeze it too hard or too soft. So it's tied to so much of what we do. Touch is really underestimated, but extremely important.
Well, I'll have a newfound appreciation when I see the rat outside my building scurrying toward the dumpster as to what that rat can teach me about human touch. All right, Neil Shubin, thank you as always.
My pleasure. Good to see you.
Good to see you too.